Yep. Where did I mess up here? So no,
Your gradient. Should be negative 5. So you've included in your counting? We're about to run through it. Alright, 3, 2, 1, and we're off the air. So we have a number of questions on the board. I thought we'd start, because we had a go at this last lesson, but I thought we'd start with a concept that I think we're struggling with from year 9, and that's question 1A, because if we can't do this, we can't do the rest of it. So I thought we'd go right back to our basics. I'm asking for a linear equation. What does that mean? What do I want? I want an equation about a line, which is?
Y equals
Yep, so y equals mx plus c. My final answer, 2 of those variables should be still there, and 2 of them should be numbers. Which 2 should still be there?
Y and X.
Y and x, and which 2 should be numbers?
M and C.
So I need to go about making 2 of those into numbers. How can I start? What's the easiest place to start? Rise over run. Or you could use your y2 minus y1 over x2 minus x1 formula. In this case, I'm happy with rise over run, so I ask myself, where does it start and where does it finish? How far has my graph dropped in my 2 known points? Some of us made the error, a lot of us made the error of they messed up the counting. So if you're struggling with that, I would always recommend physically going through and counting. So 1, 2, 3, 4, 5. So it's gone down 5, so I'd make that negative 5, divided by 1, 2. So I get a gradient of negative 2.5, or you could have left it as a fraction if you felt. So now I'm halfway to solving my problem, correct? What's the other value I need to find? From the start, I need to replace 2 numbers. Yep, so I need to get my C value. So now that I'm looking for C, I've got y equals negative 2.5x plus C. The problem with this equation is that I have 3 unknowns, so I need to get rid of 2 of them. How can I get rid of 2 unknowns here?
use a known.
Use a known value. I have 2 known coordinates here. I can pick either one. I'm going to pick, let's pick the first one here. So I've got 3, so I'm just going to let y equal 3. What has x got? It must equal now? Negative 1. So I've got 3 equals negative 2.5 times negative 1 plus c. From this point, what must I do? On the right hand side, before I can rearrange, I have to simplify. So I've got negative 2.5 times negative 1, which is just positive 2.5. Now I can minus 2.5 from each side, and I'm left with 0.5. Cool. Am I done yet? What do I need to do? Put it back into my equation. So my final answer should look like this. Y equals negative 2.5x plus 0.5. Why do I keep giving you gross numbers for these? What do I not want you to do? What's the difference? If I had this going through 1, for example, would you need to do this?
No.
Why not? You can see your C value. So I'm giving you gross numbers for 2 reasons. I want you to build your fractions, and I also want you to get used to subbing in values to find your C, because that's what we need to do with this. Cool? So if you couldn't do that, and if you're struggling with that, the next stuff becomes a lot more challenging. Very similar process, correct? What's the difference? What's the key difference? I gave you a bunch of rules about, well, I gave you 2 rules about parallel and perpendicular lines. What were they concerned with?
We know the gradient.
We know the gradient. So the only thing that changes when we're dealing with parallel and perpendicular lines is that we have to apply a formula to find our gradient rather than applying rise over run. So to say that again, the only thing that changes is that rather than applying a rise over run formula, we already know our gradient, or we have to apply the negative 1 over our gradient formula. Cool?